Salt balance is similar to water. It's just that this time we are referring to salt balance, and when we say salt balance now, we are going to refer to Na plus or sodium ions, Na plus or sodium ions, or you can simply say salt. So now fix this. Right, so that is salt, and basically what is going to happen here is as follows. We're going to look at the homeostatic control of salt concentrations. So when the salt levels decrease in the blood, right, receptor cells in the kidneys will detect that, and you don't have to know the name of the receptor cells, just know that the receptor cells in the kidneys will detect the decrease in the sodium ion levels, and therefore the adrenal gland in the kidney is stimulated to secrete aldosterone. Aldosterone is the hormone that is controlling that. So if I can make a flow diagram quickly, what do we have? We're going to have salt or Na plus or sodium ions. If sodium ion decreases here, right, then what follows is what? The receptor cells detect and stimulate. They stimulate adrenal glands, and thus adrenal glands secrete aldosterone, and aldosterone is your hormone. So they will secrete aldosterone, which is your hormone. So it's very important. So this hormone, what does it do? It actually promotes reabsorption of sodium ions into the blood. Right, so after aldosterone has been stimulated, it will therefore promote the sodium ions to be reabsorbed back into the blood, and therefore less sodium is excreted, and there will be an increase back to normal. So if you can look at this flow diagram again, you have what? Your salt level decreasing in the blood, and therefore this will be detected by your receptor cells in the adrenal glands, and these adrenal glands will secrete aldosterone, which will therefore promote the reabsorption of the sodium ions, and the sodium ions in the blood will increase back to normal, and then you'll have your normal homeostatic control there. So let us have a look at the nephron again, and it's still, we are having kidneys as your target organs. So what they're trying to tell us here is that, remember now, you still have your kidneys which filter out the waste products. So one of those waste products can be Na plus, which is a sodium ion, and of course it will travel through the nephron, proxima proximal tubule there, and then through the loop of Henle, Na plus, Na plus. But now when it arrives at the distal tubule as well as the collecting tubule, now we know what is going to happen here, because this is the point that the aldosterone will affect, right? The aldosterone will affect the distal and the collecting tubule. So you have your aldosterone. So if there's a decrease, more aldosterone is secreted, right? And if aldosterone is secreted, more of it, therefore it will promote the reabsorption of these salts. So this salt, instead of going down the collecting tubule to the urethra, where it will be excreted out with the urine, what will happen is it will be reabsorbed, so it will move out of the tubules and into the blood vessels, and therefore the amount of sodium will increase in the blood, as well as in the distal tubule it will move out and into the blood vessels, and this will cause the amount of sodium ions, or the sodium concentration, to increase in the blood back to normal when it had decreased before. So that's how the homeostatic control occurs. And what about when now the salt level increases? When the salt level increases then in the blood, then we know again your receptor cells are still going to detect the increase and will stimulate the adrenal glands to not necessarily stop secreting. It's not gonna stop, but it is going to secrete less. So it will secrete less aldosterone, and when less aldosterone is secreted, then more sodium ions will not be absorbed. These sodium ions instead will move out of the body with the urine, just like water, and more sodium is excreted, therefore it will decrease. So looking at our flow diagram here, the salt level in the blood increases, and the adrenal glands, they secrete less. They will secrete less aldosterone, and when less aldosterone is secreted, therefore the reabsorption of sodium ions will decrease, meaning they will move down the urethra and out of the body, and therefore the salt levels will decrease back to normal if it had increased initially. So going back to our diagram right here, here again you have your filtration taking place right here. So your sodium, as it will be traveling through the nephron, as it arrives at the distal tubule, instead of now having to pass down with the urine, it will therefore be, oh, by the way, we are talking about an increase in the salt or in the sodium ions. So if you are having an increase, therefore there is no need to reabsorb these sodium ions, so less aldosterone from the adrenal glands will be secreted. So you'll have less aldosterone being secreted, therefore it means these salt ions will not be reabsorbed into the blood vessels, which are these vessels that are surrounding the nephron, and therefore more of these sodium ions will be lost through the urine, and therefore the amount of salt in the blood will decrease back to normal.